Today our topic is area of triangles and quadrilaterals, and our learning target is how can I find the area of a triangle and special quadrilaterals. First piece is some vocabulary. So we have perimeter is the distance around a figure, and area is the amount of square units inside a 2D figure. So the key piece there is square units. So we have some postulates. Now this should be a lot of review from what you did last year in 7th grade or in 6th grade. So we'll kind of go through it pretty quickly. Postulate 24, area of a square postulate, that area of a square is area equals side squared. Area congruence postulate, if two polygons are congruent, then they have the same area because they're the exact same shape. And then area addition postulate, the area of a region is the sum of the areas of its non-overlapping parts. So that's like if we had a shape that looked like this, we could find the area by finding the area of this piece right here and then summing it with the area of this piece. All right, area of a rectangle, theorem 11.1, area of a rectangle is the product of its base times its height. So area equals base times height. Same with area of a parallelogram. Area equals base times height. However, please notice that the height is not the slanted side. It is the side that is perpendicular to the base. Okay, so that's one piece that's really important about parallelograms. And then the area of a triangle is 1/2 the area of the base times the height. And again, your height is the piece that is perpendicular to the base. So using this, we want to find the area of the figure. So we got a couple different pieces going on. We have a triangle here. We have a parallelogram, which we know by these arrows on each side saying that they're parallel. And then we have another triangle over here. Okay. So if we just start from the left and work our way to the right, for this triangle right here, I'm going to redraw it. We know this piece is 10. We also know it's a right triangle. We can also know that this side is 26 because it's a parallelogram, so opposite sides are congruent. To find the area of this, we're going to need the length of our height. We know our base is 10, so we have area equals 1/2 base times height. To find our height, we are going to have to use the Pythagorean theorem. So we're going to have to use a squared plus b squared equals c squared. Something we're very familiar with. So 10 squared plus h squared equals 26 squared. 10 squared is 100 plus h squared equals 26 squared, which is 676. Subtract 100 on both sides, we get h squared equals 576. Take the square root of both sides, and we get h equals 24. All right, so now we can plug that into our area equation. Area equals 1/2 10 times 24. Area equals 1/2 of 240. So the area would equal 120. And we do want to make sure we are putting our units meters squared. A lot of work for just one area. All right, so I'm going to write this up here with a little arrow. This area is 120 meters squared. Now we can find the area of that parallelogram because now we know this distance, this height right here is also going to be the height of our parallelogram and the height of this triangle because it is perpendicular to the bases. All right, so we know that the height of our parallelogram is 24 and our base is 40, so we'll do 24 times 40 for the area of our parallelogram, and we get 960 meters squared. Last piece, we need the area of this triangle, so area equals 1/2 base times height. Our base is 20. Our height is, as we said, 24. Area equals 240 meters squared. Now the area of the whole piece would be all three areas summed together. So we add 240, 960, and 120, and we get 1,320 meters squared would be the area of the entire figure. Next piece, example 2, you need to buy paint so that you can paint the side of a barn. A gallon of paint covers 350 square feet. How many gallons should you buy? So we have two pieces that make up the side of the barn. This rectangle. Rectangle is area is base times height. So we would do area equals 18 times 26. And we would get that the area is 468. Our units are feet squared. The other piece is this triangle, which if you can't see, what we know is that it's a right triangle and that these two legs are congruent. So it's an isosceles right triangle, and we know our hypotenuse is 26. So redrawing that, we'd have these two lengths would both be x, and this is 26. So set up the Pythagorean theorem, x squared plus x squared equals 26 squared. 2x squared equals 26 squared. 26 squared is 676. We have 2x squared equals 676. Divide both sides by 2, we get x squared equals 338. And then we take the square root of both sides to get x by itself, and we get x is approximately 18.4. Now we have the base and the height of our triangle. So we can find the area of our triangle by doing 1/2 base times height. And we get that the area is about 169 feet squared. So all we need to do is sum these two areas together to get our total area. And the total area would be 637 feet squared. However, if we look back at our question, it said, how many gallons of paint should you buy? We know each gallon will cover 350 square feet, so we need to do some division to figure out our gallons. So we're going to take our area, 637 feet squared, divided by 350 feet squared, and that'll give us the number of gallons we should buy. Feet squared cancel off. We have gallons equals 637 divided by 350 is 1.82. However, they don't sell paint in 1.82 gallons, so we're going to have to round up so that we have enough paint. So we should buy 2 gallons of paint. All right, next piece is 3 more area equations. Area of a trapezoid is 1/2 the height times the sum of the two bases. So remember, the bases are the parallel sides, so the ones that have the little arrows, and then the height again is that perpendicular length. Area of a rhombus and the area of a kite, they have the same equation. It's 1/2 times the two lengths of the diagonals. So times diagonal 1 times diagonal 2. Same for a kite, 1/2 the length of your two diagonals multiplied together. So let's practice this. Find the area of the figure. Area of a trapezoid is 1/2 times your height, which here would be 4, times the sum of the two bases, which would be 6 plus 8. Area equals 1/2 times 4 is 2, times the sum of 6 and 18 is 14. Area equals 28 feet squared. Area of the kite, we know that this diagonal is 14, and then we have the other diagonal is 6. So area is equal to 1/2 times the two diagonals, so times 6 times 14. Area equals 42 inches squared. And last area of this rhombus, the length of this piece is 30 and the length of this piece is 40. Well, property of a rhombus is property of a parallelogram, which we know is bisecting. So both pieces are equal. So this whole length would be 30 times 2, which would be 60. And then this whole length would be 40 times 2, which is 80. So we'd have area equals 1/2 times 80 times 60. Area equals 2,400 meters squared. Next example, one diagonal of a kite is twice as long as the other diagonal. So if we draw a little sketch of a kite, one diagonal, we'll say the red diagonal is twice as long as the green diagonal. So if the green diagonal is x, the red diagonal would be 2x. We know that the area of the kite is 72.25 square inches. So what are the lengths of the diagonals? Well, to start with, writing area equals 1/2 times diagonal 1 times diagonal 2. We know the area is 72.25 equals 1/2 times diagonal 1, which we'll call the green diagonal, x, times diagonal 2 times 2x. Multiply everything together. We have 72.25 equals 1/2 times x times 2x. Well, 1/2 times 2 is 1. And then x times x is x squared. Just have to take the square root of both sides to get x by itself. We get x equals 8.5. So that's the length of one diagonal, which would be our green diagonal. And then we would just need to figure out the length of the red diagonal by doing 2 times x. So 2 times 8.5, which gives us 17. Pick the correct answer, and that would be C. All right, one last example for you guys. I know this video is a little bit long. I apologize for that, but it is my duty to teach you. You're welcome, Anna. Find the area of a rhombus with vertices M, 1, 3. So we go 1, 3, that's M. N is 5, 5. So we go to 5 and 5. P is 9, 3. And lastly, Q is 5, 1. Connect the dots, make that rhombus that we know it is. We want to find the area. So for area of a rhombus, we need those diagonals. So this diagonal, it's nice. It's a vertical line, so we know it is 4 units. And then the other diagonal, which would go across here from M to P, it's a horizontal line, so we can just count and we can find that it is 8 units long. So then our area of a rhombus is 1/2 times diagonal 1, which is 4, times diagonal 2, which is 8. Area equals 1/2 times 32. So the area is equal to 16. And when we're working on a graph, our units are just units squared. That's all we can do. All right, I apologize for the length of the video, but thank you for watching, and please subscribe to my YouTube channel.